Hello, and welcome to session 2 of the R workshop that I've been doing every couple of years for a while now. This is the first one that I'm recording online, so I'm still learning how to do that. Forgive any technical difficulties along the way. Eventually, I will share this recording. Um, the first unit of this workshop was designed to familiarize people with what I consider the very basics of programming in R that allow you to control in intuitive ways what the software does. This session is designed to introduce you to the basics of uh, carrying out simple statistical tasks in R, which are the many of the main reasons that people want to learn it at first. Everything today focuses on um, statistical functions that are available in R by default that come with the base R installation and are in its default libraries. R has a lot of capabilities by extension through all of the packages that have been made available freely online, and we will talk more about those later, but for now I just want to talk about some of the basics of what R can do on its own. Okay, now I'm sharing my screen. Here is the basic default R GUI that comes with it. That if you're watching this after Unit 1, you will have already seen me use. And we're going to pick up with this second syntax file that I should have shared ahead of time. Um, I'm going to start by using t-tests as an example to show you some of the general principles about how most statistics functions work in R. And in order to do that, I'm going to first just create some fake data, set a few variables to use as examples. So this first example line of code should be fairly clear to you based on what I explained about the C function for concatenate last time. This is going to assign a new variable called warmth. It has the name warmth and it stores just a single vector. That's the output of this C function that contains these integers in this order. So after I run that line of code, warmth exists and it contains this vector. I'm also going to create a variable called target gender. Let's suppose that this is the data from a simple experiment in which I manipulated the apparent gender of some hypothetical person, and participants are supposed to evaluate how warmly they feel towards that person. And I am here using two functions that we talked about last time, the rep function and the C function. Here, C creates a short vector that contains these two strings, M and F, and rep will repeat that 5 times to create an overall target gender vector. Oh, I ran it twice. So just to see what that is, I'm going to run just this portion just to print the variable to the console. And of course, it is M and F repeated 5 times for a total of 10 elements. This is a character vector. The basic t-test function is called t.test, and it works just like any other function in R, just like, for example, the square root function that we talked about last time. You supply arguments in parentheses, and the function will return a value that you can then either look at directly at the console in some way, or use in some more sophisticated calculation, or store for later reference. So I want you to sort of get used to thinking of functions in R as procedures that take input and give you output that you then choose what to do with. It's always helpful to look at the documentation of functions when deciding how to use them, and the question mark is one way to do that we talked about last time. So this line of code, question mark t.test, will show us the documentation. What it's actually going to do is attempt to open my web browser. This is the documentation page for the student's t-test function. Well, sometimes it performs all other versions of t-tests besides the original student's t-test. But the key information that you might want to look at here is information about what arguments you can supply to the function in this section. And also in this section, you have some information, for example, what the defaults are for certain ones of these arguments, which can be quite helpful to know about. For example, it will default to a two-sided t-test. It will default to a null hypothesis that whatever quantity you're testing is 0, often the difference between two means. It will default to not doing a paired t-test and to not assuming that variances are equal. And you might also want to know, for example, about what the value it gives is, which is a list. Like many of the results of statistical functions available in base R, um, the output of the function is a list. Most of the time we don't care about this. We're just looking at the way that it formats it automatically at the console to see what the results are, but it can be helpful to know that this is just a piece of data like any other that you could assign to a name and manipulate in the same way that you might manipulate vectors or other objects that you've created in R. And this list has elements that you might retrieve individually, such as the confidence interval or something else, if you have some reason to keep track of those things and manipulate them. So going back to the R interface here, um, the first argument that it's expecting, well, we should see that. The first argument that it's expecting is called either X or formula. We're going to use this method for formula. And so you should think of the first argument as R is expecting to see a formula. Um, the formula specification in R is a handy way of explaining what kinds of statistical models you want to run. And it's built like many representations of what is sometimes called the general linear model. In other words, first comes the name of the dependent variable or outcome variable or response variable, and then comes a list of independent variables or predictors. So here in this example, I am using warmth as the response variable and target gender as the predictor. So I would like to compare the mean levels of warmth for each of the two target genders, which is another way of saying that I'm using target gender to predict warmth. And those are separated by the tilde character. That's how our formulas work. They all have this basic structure of response variables, tilde, predictor variables, and there might be more complex layers on top of that. When I run this line of code, it of course just produces output at the console here. That's because I didn't assign it to anything. So t-test is a function like any other, so it just produces a value, a list. But if I don't assign it to anything, which often I'm not going to assign it to anything, then I just see R's way of representing that list at the console. This is of course not the typical way of representing an ordinary list object that you might create yourself. But that's because it has details built into it that tell R how to format it in a user-friendly way when outputted directly to the console. One thing to notice about this output by default is that it specifies a Welch two-sample t-test. This is a type of t-test that does not assume that the two groups have equal variances, and it is, as we saw from the help page, the default for this t-test function. You might be more accustomed to the traditional student's t-test that assumes equal variances, and so we can carry that test out by running this next line of code. The only difference is that I added an argument. That second argument is var.equal, and the value that I've assigned to that argument for this function call is capital T, which stands for true in R. It's a Boolean value. Of course, the arguments are separated by a comma, just like we talked about last time for all functions in R. So var.equal equals f false was listed as the default value of the argument var.equal on the help page for this function. And so that's why we had to specify an alternative to that default and when we wanted to do the traditional students t-test. It's worth mentioning at this point the table function, which is helpful in situations like this. Table lets you tabulate elements of a vector, for example. And so here I am calling table of target gender just to see that the result tells me that there are 5 values of F in this data set and 5 values of M. I'm selecting things on the screen because that's the only way that I can point at stuff with this recording system, as far as I can tell based on the tests that I've done ahead of time. So that could be, obviously, in this case, I created target gender. I know that it has 5 Fs and 5 Ms, but this is something you might want to do frequently while you're analyzing a real data set, because it's often good to remind yourself how many cases fall into certain specific categories. The next thing that I want to talk about is a different data type called a data frame, which is very helpful for lots of kinds of statistical situations, because in statistics we typically have whole data sets, not just individual variables like warmth and target gender. So a data frame in R is a set of vectors of the same length. It's actually a list of vectors of the same length. And it functions a lot like a worksheet in Excel or a data file in SPSS, if you're familiar with those two applications for dealing with data. So there are some examples of data frames built into R to use in teaching situations like this one. I'm going to show you one of them now. It's called MT cars. And the reason I'm showing it to you is that it's small enough that we can print the whole thing to the console and take a look at it. So all I did was run the command MT cars with nothing else. That is the name of a data frame that is available in R by default because it comes with the software. And it printed the whole data frame to the console because I didn't say anything else to do besides the name of this object, this data object in R. And this is how all data frames are structured. They have, they're a rectangle of rows and columns, and each column is a vector that is all the same type. So this column called MPG right here contains numbers starting with 21.0 and continuing on from there. And the next column, CYL, also contains numbers like 6. And those two columns are the same length. They're vectors of the same length, which should be sort of obvious if you've thought about this kind of data structure before, because that's how a rectangular data set is by definition structured. If there are missing values, they will show up here as missing, but the length of the column includes missing values, which is why I can say that they're the same length. We'll talk more about missing data in a little while. You can reference an individual cell in a data frame with square brackets by specifying the row number and the column number if you want. So this line of code, when I run it in a second, is going to retrieve row 1, column 4 of this data frame. So just to think about it ahead of time, this is the first row, and I've selected up to the 4th column. So I'm expecting to retrieve the number 110 from this data frame by telling R to execute this line of code, which is just the name of the data frame and then this subsetting notation. So the square brackets allow me to retrieve a subset, and indeed it retrieved 110, which is the value in row 1, column 4. I can also retrieve all of row 1 by using this kind of notation. I've specified nothing after the comma, and so it retrieves the entire row. I think of this as saying empty cars such that row 1, column unspecified. And I got that full row, which refers to the Mazda RX-4. I'm not an expert on cars. I just choose this example data frame because it's about the right size for the kinds of demonstrations I want to do. I can also leave the part before the comma blank in the subsetting notation in order to retrieve all of column 4 instead of all of row 1. So of course it begins with 110, just as it should, because we saw that from before. And I think of this line of code as saying, show me empty cars such that the row is unspecified and the column is 4. So these square brackets, you can often kind of translate them to English using the phrase such that. It's also often handy to reference a column by name using the $sign. So empty cars is an object, a list of vectors $ allows you to retrieve an element within an object, and HP is the name of one of those vectors, one of those columns within the mtcars data frame. And that is, of course, the same as the fourth column of the data frame. So mtcars $HP is the same, gives me the same result as the mtcars square bracket comma 4 close square bracket. So I could use this in statistical applications, like if I wanted a tabulation of the cyl column for the number of cylinders that a car has, I can stick the square bracket notation into the function call for table as the first argument, the only argument we need right now, and it will call table with that variable, that vector, which is the cylinder column in the mtcars data frame, and tell me that of these cars, 11 of them have 4 cylinders, 6 of them have 7 cylinders, and 8 of them have 14 cylinders. Sometimes it can be convenient to view all of the variable names in a data frame, so the names function is useful for that. Names of empty cars just shows me a list of all of the column names, the variable names, and we see some of the ones that we've used for examples already, like cyl and HP. Of course, if your data frame is very wide, it has a great many columns, then you might not want to view the entire list of names at once. But of course, you can do stuff with the output of the names function. It returns a vector of strings, and so you can manipulate vector however you want by, for example, retrieving just a subset of it or looking at the beginning or the end.